So the paper finishes on an organic compound and the idea of two-stage synthesis, which you should be able to do. They devise a two-stage synthesis of cyclohexene from bromocyclohexane. So these questions rely on you knowing by heart all your connections between all your different functional groups and how to get from one to the other. So we want to suggest a structure of intermediate E and the reagent and conditions for step 2. So you could get to this one by looking here and saying, well, I'm reacting it with OH ions. This is a substitution reaction. Yeah, they just substitute there for there. Yeah, that's one of the ones we need to know. But you could look at it from this angle. Yeah, you're making an alkene. The only way we've learned to make an alkene is to do a dehydration of an alcohol. So again, it tells you, double tells you that this must be the alcohol version of what you've got there. You only need the structure, you don't need the name. And the conditions for doing that step are you need to heat it with an acid catalyst. So you can name that catalyst. We learnt it as H2SO4, but they will allow H3PO4 as well. In the next part then, the student carries out the synthesis and obtains this amount of cyclohexene from that amount of bromocyclohexane. Calculate the percentage yield of it, and you're giving your answer to an appropriate number of sig figs. That one is to 3, that one is to 3, so your final answer is also to 3. So begin always with how are you going to calculate it. You're going to do actual over theoretical times 100, or you might prefer to do the version of product over reactant times ratio. Now in this case, as most organics are, it's a 1-to-1 ratio, so that cancels out. So it's just moles of product over moles of reactant times by 100. So that's the version I'm going to go for. So my moles of product is this. My moles of reactant is that. And I just divide the 2 and I get to 44.4, which is 3 sig figs. And the last part is a mechanism. So the cyclohexene is reacted with bromine to prepare the organic compound F. So give the structure of F and outline the mechanism for this reaction. So here's our cyclohexene. We're reacting it with bromine. So this is an electrophilic addition. So arrow from the middle of that exposed pair of pi electrons there being pulled over to there, and then these electrons, arrow from right in the middle of them over to here. That leaves us with a bromine attached to one side, a positive charge on the other side, and the bromine with a negative charge here. So just make that negative charge come and join up with that positive charge, and there's our final product. So by just drawing the mechanism, we pick up all the marks because we're also drawing the product in. Just down below, then at this middle stage here, you might prefer to put a lone pair on there and just join the lone pair across to that. Either of those examples is acceptable.